Have you ever wondered how solar panels generate electricity even before they are connected to anything, showcasing their inherent power potential? Photovoltaic, or PV, open circuit voltage, often abbreviated as VOC, is the maximum voltage a solar cell or panel can produce when no current is flowing from it. It represents the potential difference across the PV device terminals under illumination, effectively when it is disconnected from any load. This voltage is a crucial characteristic for understanding the intrinsic capabilities of a solar energy system. The fundamental principle behind VOC is the p-n junction within the semiconductor material of a solar cell. When photons from sunlight strike the cell, they create electron-hole pairs. The built-in electric field of the p-n junction separates these charge carriers, causing electrons to move to the n-type side and holes to the p-type side. This charge separation establishes an electric potential difference, which is the open circuit voltage. Without an external circuit to allow current flow, these separated charges accumulate, increasing the voltage until the forward bias current, driven by this accumulated voltage, perfectly balances the photocurrent generated by the light. The magnitude of VOC is primarily dependent on the semiconductor material's band gap, the intensity of the incident light, and the temperature of the cell. Understanding VOC is essential for designing efficient solar energy systems. For instance, when configuring a string of solar panels, engineers consider each panel's VOC to ensure the total voltage does not exceed the maximum input voltage of the inverter. Monitoring VOC can also help diagnose issues in a PV array, as a deviation from expected values might indicate shading, cell degradation, or other performance problems. It is also a key parameter in calculating the fill factor of a solar cell, which is a measure of the cell's efficiency. A fascinating characteristic of VOC is its logarithmic relationship with light intensity. This means that while VOC increases with more sunlight, it does so less dramatically at higher intensities. Another important aspect is its inverse relationship with temperature. As a PV cell's temperature rises, its VOC decreases by a predictable amount, typically around -2 to -3 millivolts per degree Celsius per cell. This temperature dependency is a critical factor for system design, especially in hot climates, and it is why the nominal operating cell temperature is a key specification for PV modules. Ultimately, recognizing the characteristics of PV open circuit voltage empowers you to better understand the theoretical limits and real-world behavior of solar cells. It helps in predicting performance under varying environmental conditions and in making informed decisions for optimal system configuration, ensuring your solar energy endeavors are both effective and reliable.